Hi guys. So today we're going to be talking about motion, yeah? So motion, or also known as kinematics, is basically the study of how objects move in terms of their velocities, their acceleration, the distance they cover, and more importantly, the time it takes for an object to move certain distance, basically. So there are some important variables we need to firstly understand in this topic, okay? Small a stands for acceleration, usually given in meters a second squared. T, small t, gives time in seconds. S usually stands for distance traveled, usually given in meters. U is usually initial velocity, alright, given in meters per second. And V is final velocity, alright, final velocity of the time frame we are interested in, depending on the question, again in meters per second, alright. More importantly, A, U, and V, you must remember that these are vector magnitudes, alright? They're vector quantities, which means their signs do matter. A positive A and a negative A both are different things because they're traveling or accelerating in different directions. And direction is something that we define in the start of a physics problem by ourselves, alright? So here are the kinematic equations that you should by heart by now, okay? So firstly, we have S is equal to U plus V over 2 times T. Alright, this is basically meaning the average velocity times time gives you the distance traveled by the object, okay? The next equation is basically V squared equals to U squared plus 2AS, alright? S is equal to ut plus half at squared. Another one is S is equal to vt minus half at squared when we don't know the initial velocity. Last but not least is, of course, the simple equation V equals to U plus AT. So all these equations will basically give you every answer you could possibly imagine in this whole topic. It is also going to give you a heads up. It's going to help you with projectile motion problems that we're going to be demonstrating today. Furthermore, I'm also going to be talking to you about velocity time graphs, distance time graphs, and acceleration time graphs, alright? Just a note to remember, and usually in high school physics, the acceleration is usually constant, alright? Just to make your problem solving techniques a bit simpler, alright? Furthermore, in projectile motion problems, alright, the key to answering these problems is to simply split the vectors up. So, for example, projectile motion usually involves launching objects at an angle, perhaps like this, alright, and then they fall down. The initial launch condition is always going to be an angle, alright? So first job is to split that velocity up into the vertical velocity and the horizontal velocity. And then we treat those two velocities separately, alright? The only thing linking these two velocities is time, okay? Because time does not stop for anyone. Last but not least, guys, I can't emphasize this more. Respect the signs in this topic, alright? Students always make this mistake. They go into an exam, they think, oh, why is the answer negative? I don't like negative numbers, so you know what? I just don't feel like giving a negative answer. I'm going to make it a positive, and I'm going to give it that. But reality is wrong. Signs are there for a reason. They're there to help you. Even though it doesn't look right, if you really think about it, it is right. Okay? So respect the signs and respect the formulas, and you should do really well on this topic. Let's go have a look at today's demonstration.
Hi guys, today's demonstration is going to be about motion graphs. I'm sure you guys know how to read a velocity time graph, so I'm going to skip that. Just a key tip is to basically always remember to analyze the question first and look for key information so that you can plot these points first, yeah? Once you have those points on the graph, then it's quite easy to just connect the lines together. Alright, two important things also I like to emphasize here is basically look at the slope and look at the areas, okay? They can tell you very important pieces of information. A slope is basically when you take the y-axis and divide it by the x-axis. So in this case, take meters per second and divide it by seconds, you get meters per second squared. which is acceleration, yeah? So basically, the slope of a graph, a VT graph, will tell you acceleration. The area under the graph is basically your y-axis times the x-axis, all right? Which is basically meters per second times seconds, giving you meters. So what's in meters? Displacement. So actually, the area under VT graph gives you displacement information, all right? So basically, use this to really help you when solving problems like the one below. Let's first analyze the problem. From 0 to 10 seconds, okay? Let's just draw an AT graph, as the question gives us AT, yeah? 0 to 10 seconds, she is constantly accelerating at 2.5 meters per second squared, okay? For 10 seconds. After that, for 20 seconds, she rides at a constant speed, which means her acceleration will be 0, yeah? So for the next 20 seconds, acceleration is 0, bringing the total time to 30 seconds. Now, in the next 5 seconds, she decelerates, okay? So decelerates negative acceleration for 5 seconds until her velocity is 0, okay? So basically, that's the line that we want to find. What's her decelerating rate, okay? And this is, of course, 5 seconds, 35. Now, as we deduce above, the area under an acceleration time graph gives us, let's have a look, meters per second squared times seconds gives you meters per second. So basically, to find the speed that she is traveling at in the middle, all you do is find the area under here, which gives you 25 meters a second. Now, she has to basically decelerate from 25 to 0 as well. So both these areas must be equal, right? We know this is 5. Okay, so can you find this by yourself? Exactly, it's not too hard, all right? Answer is 5 because 5 times 5 is 25. So the answer is basically A equals to negative 5 meters per second squared. Okay, moving on, what is the total distance covered? To find total distance, we first need to plot a VT graph, as shown here. So basically, she accelerates constant speed and then decelerates down there. Okay, sorry, that should be 30 and that should be 35. My bad. And the answer is simply the area under the graph. All right, so you use your trigonometry and square area rules to find the area. It should give you 687.5 meters. All right, let's solve some kinematic problems, all right? Remember, these equations are fairly straightforward. Respect the signs and respect the equations and you'll get the answers right. Question 1, all right? The winner finishes at 40 meters a second, all right? So that means V equals 40. Acceleration is 10, as we can see there, and the time is the last second, so T equals 1. They want us to find S, okay? So look back in this equation and find which equation has S is unknown and VT and A is known. As we can see, it's that one there, okay? So simply solve the equation. S equals to VT minus half AT squared. Okay, remember that the drag car is not decelerating, okay? It's accelerating. So A is not going to be negative here, okay? So S simply equals 40 minus half times 10 times 1 squared. That's 1 as well. So basically 40 minus 5, which is 35 meters. Done, guys. It's simple as that. Next one, okay? Number 2. Basically, a car's traveling at that speed, so U equals 25. A koala is seen. Oh, wow. That's scary. And the distance between koala and driver is 40, okay? But let's... All right, so S equals 40, okay? Let's put a star on that. If the car's anti-lock only allows a maximum deceleration of 10, okay? So A will basically be equal to negative 10. Will the driver stop in time? All right, so basically we deduce that V equals 0, okay? Because we want the car to stop. And we want to check how long is the S. If S is less than 40, then the koala is safe, all right? So you got to use your problem solving skills to deduce that by yourself, okay? Now let's look at the equations, okay? We have U, A, and V. We want to find S, Okay, we have no t. So the only equation that doesn't have t is this last one here. So let's use that equation, guys. V squared equals to u squared plus 2as. All right, replace all the terms in there. We basically make s the subject of the formula, becoming s equals v squared minus u squared over 2a. Yeah. And we plug in the numbers. Solving the equation gives me s equals 31.25. So the koala is safe, guys. And honestly, there's nothing to it, okay? Look at the unknowns, look at what you know, and then look at which equation to choose. And you should do really well on this topic if you concentrate and give respect to the signs. This topic is a bit more complicated, okay? So for projectile motion, it's the same equations once again. However, the key is to basically split the problem up into horizontal and vertical components and then solve them independently. Remember, the only thing linking them is time. Okay, let's take a crack at this one. Helicopter, yep, is basically wants to deliver a package. So it's located 200 meters above the ground. Okay, and over here there are some hikers. Okay, let's make that X. That's the target. They want you to find this distance between the target and the helicopter. Okay, because they want to deliver a package. And the helicopter has a horizontal velocity of 10. Okay, so first, what is the initial velocity of the helicopter? The vertical component is 10, and sorry, the horizontal one is 10, and the vertical one is 0. Yeah, because it's not going down, it's staying at a constant height. Okay, so basically this is simply a free fall problem, okay, starting from 0 meters a second. So first we're going to analyze the vertical component, find the time, and then link that time with the horizontal information, and then we will basically find the d here. Okay, let's just have a crack at it. So u equals 0, v equals unknown, and basically s equals 200 meters. Yep. And time is unknown. For the more we know, acceleration is 9.81. We're going to keep it positive because we're going to define going down to be positive, okay? In this case. So this is for your vertical component, okay? So the equation to be used for this one, just look back up and you will find that v equals u plus at gives you sufficient room to find the answer. It gives you the final v to be 60.8, which will be useful for later, not for now. And to find distance, we simply use s equals ut plus half at squared. Okay, so replace all the values in there, and you'll find that time equals 6.39 seconds. Beautiful. All right, take that time and put that into the horizontal equation. Okay, so horizontal equation will basically have u equals 10 because the horizontal velocity was 10. V equals will be 10 as well because there's no air friction, yeah? Um, yep, T is 6.39. S is unknown. So, and A is equal to 0. Okay, so simply use the same equation. Um, and we can find that S equals to 63.9 meters. And there you guys have it, 63.9 meters. All right, guys. So let's answer the last question on this problem. Yeah, what speed will the package hit the ground? So in order to answer this question, we need to know the velocity in both directions, the horizontal and vertical, and that's the main reason I calculated v equals u plus at. I'm sorry I didn't explain that earlier, but basically this tells us the final vertical velocity will be 60.8 meters a second. So let's draw a vertical component and put 60.8. So what's going to be a final horizontal component? As you can see here, the initial and final are the same, okay? Which means it doesn't slow down because there's no air friction. So we're going to draw a vertical horizontal component here. And the velocity that we're interested in is basically this one here. So in order to find that length, all we do is our Pythagoras, which is 10 squared plus 60.8 squared, and square root everything. And that will finally give us a velocity that we are looking for, which is I calculated to be 61.6 meters a second. All right, so that's the velocity the object will hit the ground with. I really hope you find this tutorial useful, and I'll see you in the next video.